Okay, so we are starting with the question of November 2005. November 2019, question 5. That is where we are supposed to begin. And if that's where we are supposed to begin, the question reads, a businessman has 3 alternatives open to him, each of which can be followed by any of the 5 payoff conditional possible events in millions of shillings as given below. We are required to advise the businessman on the best alternative at the maximum criteria. So that question comes from the topic we call decision theory. From decision theory. So already the examiner has computed the payoffs for us. So as ours is just to make the decision. So starting with maximum criterion. Maximum criterion. Maximum criterion. What you do, you have the option here. You have the option here. We have the option, and then you pick the minimum payoff. The minimum payoff. So the first option is A. So I want you to look at the payoffs in A and you pick or you tell me the minimum. The minimum of those payoffs in option A. The minimum of those payoffs is what? Yeah, minus 12. Let us go to B, and you also tell me in B what is the minimum. In A, the minimum is it minus 6? Yeah, minus 6. And in C, what is the minimum? In C, the minimum is 0. So this rule says you are supposed to select the maximum of the minimums. You are supposed to select the maximum of the minimums. So the maximum of the minimums is this one. So you select that. And then based on that, you now offer your advice. You offer the advice. The question had required you to assess the best alternative. So you tell them best alternative is C. Best alternative is C. We move to the next one, max criterion. Max criterion. Max criterion. Now in max criterion, once again, you have the option here. And then you extract the maximum payoff. You extract the maximum payoff. So for option A, tell me what is the maximum payoff. In A, what is the maximum payoff? Yeah, I'm told it is 6. Good. In B, what is the maximum payoff? In B, the maximum payoff is, yes, 16. And in C, the maximum payoff is 12. The maximum 12, the maximum payoff is 12. So, according to this, you are supposed to take the maximum of the maximums. So the maximum of the maximums is this one, 16. So when you have that, then you see the advice. The advice is that best alternative is B. Best alternative is B. The next one is Howick's rule. Howick's rule. I want to bring it up here. So for the Howick's rule, we have the option here, and in this we say alpha times best payoff plus 1 minus alpha times worst payoff is equal to weighted average payoff. Weighted average payoff. That is how you compute it according to Howick's rule. This option, alpha times best payoff plus 1 minus alpha times worst payoff. So when you go to A, alpha we are told is 0.6. The best payoff in A is 6 plus 1 minus 0.6 multiplied by the worst payoff there is minus 12. So multiply that and give me the answer. Waiting for the answer. Here's Diogo, Halima, Jacob, minus 1.2. Minus 1.2. Let's go to B. You also say 0.6 times the best. The best in B is 16. Plus 1 minus 0.6 times the worst. The worst in B is minus 6. Minus 6. $7.2 according to Theo. 7.2 also according to Joyce, Harima. Good. Let's go to C. You say 0.6 times. The best there is 12 plus 1 minus 0.6 times the worst there is 0. The worst there is 0. So give me the answer there. Give me the answer. Okay, again, I can see 7.2 flowing. So with that, we are supposed to give the advice. And the advice, we are supposed to go for the highest. And because the highest are 2, they are equal, the advice will be best alternative. Best alternative is either B or C. Is either B or C. So they select on one of them. They select one of them. But if they want to specify which one, then what you do from there now that they have time, you compute risk. You compute the standard deviation and the coefficient of variation for each B and C. Then depending on whether the decision maker is a risk taker or risk averse, you advise them appropriately. But for our case, in order to get to that extent, this one is sufficient. The next rule is called Rapri's rule. Rapri's rule. Now, in the Rapri's rule, we have the option here. Then we have sum of all payoffs. Sum of all payoffs. You divide by number of outcomes. Number of outcomes. And this gives you something we call simple average. Simple average payoff. Simple average payoff. You get simple average payoff. So for option A, you will take 6 plus 2 minus 2 let me put it this way, plus minus 2 plus minus 12 plus 4. All this you divide by the outcomes. 1, 2, 3, 4, 5. So you divide by 5. You divide by 5. Give me the answer. Minus 0.4. That is according to Halima, Biongo, Kaltuma. Good. Joyce, so that is confirmed. Let's go to part B. Part B, you take minus 6 plus minus 3 plus 10, 16 plus 0. All this you divide by 5. All this yeah, 3.4. Arima, Joyce, Diogo, good. 3.4. And then part C, we also do the same thing. Okay, this one, put it here to be the answer. Do the same on your own and send me the answer so that I confirm that we are together. Send me the answer. Yeah, Joyce said it is 6. Rima agrees. Even Anne, Fiongo, good. So the answer must be 6. So then you offer your advice. The advice is the best alternative is C because we go for the highest. So the best alternative is C. So let us go to part B. A manufacturing firm produces 2 products, X and Y. The standard revenues and costs per unit of the product are as follows. So we are given all that. Packaging is separate, automated task, and the costs relate to materials and electricity. The maximum available inputs per week are limited as follows. The profit of the company could be increased by increasing the selling price of product Y. Now formulate and solve the above linear programming model graphically. You formulate and solve that question graphically. That must be a very simple question or a very difficult question. Don't know what you think. Is it simple or difficult? What do you think? What do you think? Very simple or very difficult? Yeah. I have no opinion. There is a saying 50-50. The question of November 2019, question 5B, is on linear programming. Is on linear programming, graphical. Is on linear programming, graphical methods. So in solving this, the first thing to know this one is to get the formulation. And you know, formulation has 3 steps that should be taken for you to be able to formulate. First of all, you must tell us the units. You'll say let X represents units of product X produced and sold. Produced and sold. Y to be units of product Y produced and sold. Produced and sold. Produced and sold. Then objective function. Objective function is to maximize sales. So I need you to tell me the contribution margin of product X. Contribution margin of product X. And remember, contribution margin is the selling price minus variable cost. So give me the contribution margin of product X. Contribution margin of product X. Contribution margin of product X is how much? Yes, good. I can see 8 there coming in. So 8x plus, give me the contribution margin of product Y. The contribution margin of product Y. Yeah, good. Can see 60 coming in. 60Y. Now this is subject to we start with materials. Now, if you go to where you can see material, you can see 1 kilogram of material is going for 20 shillings. So if product X has, Nancy have said contribution margin is selling price minus variable costs. Selling price minus variable cost, confirm. So I was saying that for material, if 1 kg is going for 20 and X has 80, how many kilos are those ones? How many kilos are those ones? Nancy, have you confirmed? Okay, Halima, not that way, it is the opposite. The opposite, Halima. So we will have 4x. Are you okay now, Halima? Good. So if that is true, then for y, we will have how many kilos? How many kilos have been used for y? They are also 4. So 4y is less than or equal to, when you go down there, you find that material has 240. So this is material. That is for material. If you argue the same way when you go to labor, where labor 1 hour is paid for 16 shillings, labor 1 hour is paid for 16 shillings, then X, which has 64 shillings, how many hours are those? How many hours are those? Okay, they are also 4. So 4x plus, when you go to y and argue the same, how many hours are those for y? Yeah, 2y. It's less than or equal to 200. And this is because of labor. That is because of labor. If you argue the same way for packaging, then you will get 1x plus 2y is less than or equal to 100. And this is what we call packaging. It's what we call packaging. It's what we call packaging. And then we said you must bring another one here. X plus y is less than or equal to, not plus. X, y should be greater than or equal to 0. And this is called non-negativity. 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 Then from there now, you seek to create the coordinates. You seek to get the coordinates. Coordinates. So the coordinates want to get coordinates, starting with the first equation here of 4x plus 4y is equals to 240. So we say here xy we divide it into 2, whereby you say if x is 0 here, y will be 240 divided by 4, which will be 60. And if y is 0, then x also will be 60. Then we go to the next one, which is 4x plus 2y is equals to 200. 4x plus 2y is equals to 200. So if this is x and this is y, x and y, if x is 0, then y will be 100. And if y is 0, then x will be 50. X will be 50. And then x plus 2y is equal to 100. X plus 2y is equal to 100. So x here so if this is 0, this must be 50, and if this is 0, then this must be 100. That must be 100. That must be 100. So from there now, we come up with the graph. We come up with the graph. That is the next step. So the next step now is plotting. The graph. And I told you what to do is to first of all check the scale by identifying the highest values. And you can see along x-axis, the highest is 100, and along y-axis, the highest is 100. I also advised you on how to come up with a good graph. The graph must be at least have a page. But myself, because of the space and the camera, I will not comply with have a page issues because of the size of my camera. So you seem to come up with a very nice graph. So this is x-axis, and this is where I have units of product X, units of product X. Then this is 20, 40, 60, 80, and 100. This is y-axis. And this is where we have units of product Y, units of product Y. So in protein, 60, 60. So this is 4x plus 4y is equals to 40. Then y being 100 here, this is 50. So my 50 is here. So 150 here. So this is the equation of 4x plus 2y is equals to 200. And then 50 here. And this one here. This is the equation of x plus 2y is equals to 100. And like what we did in class, labeling all the corners, here we shall just label the one that will be of interest. You can label this to be corner A, this one to be corner B, this is corner C, and this one you call it B. And remember now, this is our feasible region. This is our feasible region. So that you shade on this side. This way. You shade like this. So when you get there, you write finish or you write the word there so that I can proceed from there now when we are together. Good, we have finished. Jacob, I don't know where they went to. I have no idea. So if we are finished, the next thing now is interpretation. Interpretation. Now for me, I'm going to squeeze them here, but you bring them down. Don't squeeze them in the graph page. So interpretation now. Interpretation. Interpretation. So what I need to know is the optimal corner. I need to know optimal corner. Optimal corner. Now, optimal corner is the corner that is farthest from the origin. Here. And I told you there are many ways of identifying it. One, you just check visually. Naangalia tu kwa macho. Unaona between these four corners, A, B, C, D, which one is farthest from the origin? Kama macho haisaidii, unachora, unawekelea rula hapa. Unawekelea rula hapa, and you start moving it that way, and you tell me the last corner it will touch. The last corner it will touch. Let's try those two ways. So tell me which corner is farthest. Yeah, Jacob says he can see C. Yeah, good, and C. Yeah, Malda, Nancy, yeah, so that is confirmed, is corner C. Corner C is the farthest. So give me the coordinates of corner C. Corner C, X is 40. So the coordinates are 40 and 20. Those are the coordinates. The next thing now is to give us optimal production. Optimal production. Optimal production, we have the products and we have the units. The products and the units. The products and the units. So this one is very straightforward. Product X and product Y. X is this 40, so 40 units. And Y is 20. Y is 20. The next item that you need to tell us, in as far as interpretation is concerned, is maximum profit. Maximum profit. So maximum profit, you take these ones. We know we have decided to make 40 units of X. 40 units of X. You multiply by the contribution margin, which was 80. Contribution margin, which was 80, plus 20 multiplied by the contribution margin, which was 60. Which was 60. How much? Yeah, 4,400. 4,400. Good. The last interpretation that we require is resource and the status. We have resource here, and then the status. The status here. So the first resource is material. Now material is represented by 4x plus 4y. Now 4x plus 4y, you can see it has touched the optimal corner. So if it has touched the optimal corner, that resource is binding. That resource is binding. Then we go to labor. Labor also has touched. This one, you can see it is part of the optimal corner. So it is binding. It is binding. And the last resource is packaging. Now packaging has not touched the corner. You can see it has not touched the corner. So if it has not touched the corner, it is non-binding. It is non-binding. So that is how you interpret or you solve a linear programming problem graphically. Now from there, if we are okay, we are supposed now to determine the maximum selling price. So we are told to get the maximum selling price. So maximum selling price. So for us to get maximum selling price, we need to get maximum contribution margin. Maximum contribution margin toward the variable costs. Toward the variable costs. Toward the variable costs. So for product Y, variable costs. What was the variable cost of product Y in the question paper? It was 300. Good. It is shillings 300. Sensitivity analysis for contribution margin, sensitivity analysis for contribution margin. We are still dealing with products. Why? I told you for contribution margins, you take the equations of the binding resources, The first one is 4x plus 4y is equal to 240. And because we are dealing with product y, we make the other one x. So x becomes the subject. So it will be 240 out of 4 minus 4y out of 4. Then you take the next binding resource, which is labor, 4x plus 2y is equal to 200. So x must be 200 out of 4 minus 2y out of 4. Those are the binding resources. You already have changed them. Then from there, we say you multiply. Multiplying, I told you, you take this row, 4 out of 4, and you take it as positive. You multiply by the contribution margin of x. Contribution margin of x was 80. So that gives us shillings 80. And then you take this other one, 2 out of 4 multiplied by 80, that gives us shillings 40. And then from there you select. From there you select or you label, and this becomes the maximum, and this is the minimum. That becomes the maximum and the minimum. So we say thus maximum selling price will be equal to 80 plus 300, and that is shillings 380. That is the maximum selling price. If you are okay, say my yes, so that I can proceed to part C of the question. Why do you want 80? How many x? Sorry, yeah. My workings are okay, Jacob. This was the contribution margin of x. And that's how it's supposed to be. You okay, Jacob? Are we okay? We proceed. Fatima says yes. Yogo, Joyce, Nancy. Okay. Contribution margin, Halima, is the difference between selling price and variable costs. Selling price and variable costs. Okay, we have gotten that. Let us go to part C. What I have done is the correct thing, Halima. Maybe you check your notes later. Check your notes for more details, how it's supposed to be done. This is the correct thing. Okay. John Wekesa is the manager at Mikate Bakers Limited. He intends to establish the cost of each bread. He gathered the following data on the total cost of each day's production for the last 10 days as shown in the table below. So you are required to get the cost function and then you get the break even. So the question Question 5C now is coming from regression and correlation theory. Regression and correlation theory. Regression and correlation theory. So we are told to get least square function. Least squares function. So I told you in dealing with this one, the first thing is to give us the format. You tell us you know the format is y is equals to a plus bx. Then from there, you tell us the formula. The formula for b is given as n sum of xy minus sum of x sum of y. You divide this by n sum of x squared minus sum of x. You square this. And then the formula for A is sum of y minus b sum of x. You divide by n. You divide by n. Then from there, you prepare the analysis table. You prepare the analysis table. The analysis table. And this analysis table, we said it has several columns. The first column you bring is the column of x, which has 4,500, followed by 4,200, followed by 5,500, followed by 4,300, followed by 6,000, then 4,000, 4,800, 5,300, that is 6,600, and that 400. So those will be the values of x. The values of x. Okay, then we go to the values of x, the values of y. The values of y, we have 46,000, 46,000, 43,200, 46,600, 48,000, 56,400. Then we have 44,800. Then I have 46,200. 50,600. 40,200. And then that's 3,000. So that is the second column. Yes, Jacob, I can see that. So if you want to use the calc as Jacob is requesting, make sure you follow instructions. You follow instructions as they are coming. Chukua your calculator. Chukua your calculator and try to follow. We said you press mode until you see regression. You press the number below it. And then you see linear, you press the number below it. Make sure you're following because I may not get time to repeat. Then you start entering the values. 45,000. No, not 45,000. 4,500. Naweka comma. 46,000 M plus. 4,200 comma. 43,200 M plus. 5,500 comma. 46,600 M plus. Then 4,300 comma. 48,000 M plus. 6,000 comma. 56,400 M plus. 4,000, 44,800 M plus 4,800 M plus 46,200 M plus 5,300, 50,600 M plus sorry, this one should have been 3660. 3660 because it's 36.6, so it's 3660, 40,200 M plus, and then 3,400, 3,000 M plus. That is how you enter the values. Then for you to get the totals, I told you you press Shift, button number 1, and after easy values, totals. So for X is number 2 equals. So the sum of X, I'm getting 45. I'm going to be able to say what you have gotten, whether you have followed. Save the answers. Said the answer, the sum of X. Yes, get 45,660. 45,660. Then you shift button number 1. You replay forward to double to get sum of Y, which is number 2 equals 455,000. 455,000. Then you come here. Remember, if you did not follow, not much of a problem. You just do it manually. Then we come here. You get X squared. So X squared, sum of X squared is 1. That is 214,715,600. I also require a column of XY. So shift button number 1. This will be 2,118,012,000. So Harima and anyone else who has not followed, if you have not followed, not a problem. You just fill in the columns. Kama hasa hii useme 4,500 squares. Unaandika hapa 20,250,000. 4,200 squares. Unaandika 17,640. Naendelea namna hiyo unatafuta total. Ukienda huko kwingine unasema 4,500 times 46,000. Unapata 207 million. Unakuja kwa hii vile 4,200 times 43,200. 181. 440. Yeah. So you don't have to be stressed by the issues of the calculator. Unatembea tu pole pole hivyo, the answers will be the same. That's okay, Halima? Okay. After that, now I told you the next thing is to substitute The next thing is to substitute. The next thing is to substitute. The next thing is to substitute. So tunasema substitution. So we start with the value of B. B, according to our formula, is 10 times sum of xy 2118 0112 minus sum of x, which is 45660 times sum of y 455,000. You divide all this. You divide all this by 10 times sum of x squared. That is 214, 715, 600 minus sum of x squared. 45,660 times 45,660. So if you're using the calc, you say shift button number 2. You will play forward to where we have B, which is number 2 equals. Get the answer. If you're not using the calc, you just solve kawaida and give me the answer. So give me the answer, whichever method you're using. Give me the answer for B. Yes, Diogo is giving 6.4 and good. Yeah. You have used how many decimals? You're using 4 decimals. So 6.4958. Good. So the others confirm the figures. Whether Diogo and Anne are accurate. Yes, Jude. Jacob, good. So those are good enough. Let us now get the value of A. The value of A is the sum of y, which is 455,000 minus 6.4958 times the sum of x, 45,660. You divide by n, which is 10. So once again, send me the answer. If you are using from the calc, you're getting it from the calc, you say shift button number 2. You will play forward up to where we have A, 1 equals. If you are solving manually, you just go kawaida, give me the answer. Yes, today 15,840. 15,840.24. Joyce 1.8. Yeah, it could differ kidogo depending on how you have used your decimals. But let's go by this. It's the one you're getting from the calc. But kama umetumia manual ndio unapata 0.18, 0.17 Halima and Joyce, but they are okay, they are acceptable. They are okay. Okay. So thus cost function will be y is equals to 15,840.24 plus 6.4958x. Here's Nancy, I can see that. So that is the answer to that bit where they wanted us to tell them the function. The next thing they are requesting us to get is if each bread is sold at 50, predict the break-even number. Predict the break-even number. You predict the break-even number. So that one is something again we know very well. Break-even point. Break-even point. Now we know at this point, total revenue should always be equal to total cost. Total revenue should always be equal to the cost. So let X represent units produced and sold. Produced and sold. Units produced and sold. Then at break-even point, our revenue will be 50x. It should be equal to our total costs. So from there, tell me X is supposed to be how many units? So for X from there, and tell me how many units are those? Yeah, 364 according to Jacob, according to Thiomo, 364.11. Yes, Joyce. Now these ones, you can either use them like this or you round down, but the best in practice will be to round them up. So nimesema unaweza tumia kwa exam, unaweza iacha at 364.1 or whatever. Ama you round down to 364. That is okay in academics. But remember, this is a professional course, so practically you cannot have a 0.1 unit. So it must be the fifth one. Because the fourth one will not be enough. You require more than 4. So you go to 5. 365. So all the 3 are acceptable. And if we are okay with that, I would wish to proceed to the next question. Are we okay? Nancy is okay. Even Halima and Jacob, Joyce, good. So let's proceed to the next paper. And before I forget, as you saw, we are now recording the classes and posting them in your groups. Like now, this one will be recorded and posted in your group in the course of today. But because the evening class is slightly ahead of you, you can also access those videos. You can access them in my channel. I'll upload them in my channel because they will not be posted in your group. You can check in my YouTube channel that goes by Mwalimu George Kimani. In the course of the day, you can go to that channel in the YouTube. You will find like what I did yesterday, and I'll be uploading them there. So you can check there in the YouTube. And when you get there, you can also consider to like that channel and subscribe. You can also consider to like that channel and subscribe. Okay. So we proceed. That is the paper of May 2019. Question 1. The marginal revenue and average cost functions of Biashara Limited are given as follows. So we are given that, and then tunaulizwa we get the profit function and the maximum profit. And the maximum profit. So that is the paper now of May 2019, question 1A. That question has come from the topic we call functions, and specifically profit maximization. Profit maximization. Specifically, profit maximization. So you are told to get the profit function. You are told to get the profit function. The profit function. So you begin this by saying that for us to get total profits, we must have with us total revenue, we must have total revenue and we less total cost. Total revenue minus total cost. Total revenue minus total cost. So looking at the question at hand, what we have been given is, in regard to cost, is average cost. So we will get that average cost as 2Q minus 10 plus 25, you divide by Q. Now this one, we need to multiply by Q. We need to multiply by Q. So when you multiply, it opens up as 2Q squared minus 10Q plus 25. That is how it opens up as your function for the total costs. We now seek to get the total revenue. Total revenue. So total revenue, the question has given us marginal revenue. So if you have marginal, you must integrate. So integrating 40Q minus 3Q squared minus 3Q squared with respect to Q. With respect to Q. So integration proceeds like this. 40Q, which is currently raised to power 1, you add back 1, then you divide by the new power, 1 plus 1, minus 3Q squared, you add back 1, divide by the new power, 2 plus 1, and then you add the constant of integration, C. You add the constant of integration, C. So this one adds up as 20Q squared minus 3, not 3. 3 will cancel already. So minus Q cubed plus 0. For the revenue function, the constant of integration is 0. And thus profit, which is represented by pi, before I go to pi, my total profit should be equal to, into brackets, 20Q squared minus Q cubes, you minus the cost function, which is 2Q squared minus 10Q plus 25. Plus 25. And when I seek to open the brackets, I will say pi is equals to 20Q squared minus Q cubed minus 2Q squared plus 10Q minus 25. Minus 25. So, putting items together, I proceed and get that by this 20Q to join this one. I'm left with 18 cubes squared. This cube has no colleague, so cubes. Then this 10 haina mwenzake, so plus 10 cube minus 25. Minus 25. So that is the profit function. That is the profit function. With that, we are told to get maximum profit. So proceeding down here, where I wish to get maximum profit, I told you begin by saying for maximum profit, the differential of phi with respect to q should be 0. That is, we differentiate this one. When you differentiate that, you'll be left with that 6q left with that 6q minus 3q squared plus 10 being equal to 0. Then you tell us using quadratic formula, which we know is q is equal to minus b plus or minus b squared minus 4ac. 4ac. This one, you get the square root. You divide by 2a. So this one proceeds to become minus 36 plus or minus 36 squared minus 4 times a is minus 3 times c, which is 10. Which is 10. So sasa hii maneno kwa namna hii, you divide here by 2 times a, which is minus 3. Which is minus 3. And the journey proceeds here to become minus 36 plus or minus. This is 36 square, it will become plus 4 times 3 times 10 equals. Square root of the answer is 37.63. 37.63. Now this one to be divided by minus 6. And it proceeds to become minus 36 plus 37.63. You divide by minus 6, or minus 36 minus 37.63. You divide by minus 6. And proceeding, my sub, I'm able to get minus 36 plus 37.63 divided by minus 6 as negative 0.27 all minus 36 minus 37.63 equals divided by minus 6, 12.27. 12.27, and because we cannot have a negative unit, we decline the negative and say this is 12.27, which, as I have said, you can either leave it that way or you can choose to round it up to 13 units. And hence, we are looking for maximum profit. Maximum profit. You will say, you just put in this function, E function 18 times 13 squared minus 13 cubed plus 10 times 13 minus 25. So if you argue that way, it should be 18 times 13 squared minus 13 cubed plus 10 times 13 minus 25. I'm getting 950. Is that okay? If you are okay, say my agreed. Nancy, Kamatuma, good. Yeah, Joyce is also in agreement. Fiongo. Joyce, you're asking whether the exam is still on. It is very, very much on. Very, very much on. We have not had any information that it will not be there. Neither have we had any signal that it will not be there. So all systems are set to go. Just a few days from now. Just a few days. So keep your house in order, Joyce. Okay, so we then call it a day at that point, and then we hope to meet in the next lesson. So as I told you, in the course of today, you can get to my channel. You might access some recordings for some classes, still for revision, which could be helpful. At least for today, by evening, you should get one. This one is going to be uploaded in your group a few hours from now. Thank you so much.